In this example, we have a block with a 5 kilogram mass is hung from a pulley with radius 15 centimeters and a mass of 8 kilograms and released from rest. First, we're asked to find what is the speed of the block as it strikes the floor 2 meters below its initial position. So we're going to use conservation of energy to approach this problem. Much like our previous example, the initial energy is equal to the final energy. At this initial moment, it's at rest, so we only have gravitational potential energy of little m, the block itself. Just before the collision with the floor, we have rotational and translational kinetic energy. The pulley is rotating, so we'll have KER, and then plus the mass is translating downward, so KE for the mass. And so we can go ahead and put in our expressions. So mgh equals 1/2 I omega squared plus 1/2 mv squared. Now again, we're dealing with a solid disk, so we're going to be able to use that our rotational inertia is 1/2 mr squared. And just like before as well, we're going to put that in for I, and we're also going to put in that idea that omega is the tangential speed divided by the radius of the pulley. And that's going to allow us to find the tangential speed of the system, or the speed of the block. So continuing to substitute things in, mgh is 1/2 times 1/2 big M r squared times v over r squared plus 1/2 mv squared and then from here, just some algebra. I'm going to go ahead and simplify some things. So mgh equals 1/4 big M v squared plus 1/2 little m v squared. And then I'm going to go ahead and factor out the v squared on the right. So mgh is v squared times big M over 4 plus little m over 2. And then just going ahead and dividing both sides by the big M over 4 plus little m over 2. We're going to get v squared is mgh over big M over 4 plus little m over 2. And then we're going to want to square root both sides. All right, so that's our expression. In this case, we actually have numbers. So we can go ahead and put in those values. Little m was 5 kilograms, g's 9.8. The initial height was 2 meters above where it ended. And then the big mass was 8 kilograms. So 8 over 4 plus 5 over 2. All right, and then when we solve this, we get about 4.7 meters per second. And so that is how fast the block is moving before it strikes the floor.